Alrighty, Unit 2, Lesson 1. Actually, this is Lesson 2. You will be able to graph and translate and move general graphs, also known as piecewise graphs. This is such an important lesson. This lesson is the foundation of everything from here through the rest of this year and so much more. So if you didn't get it in class, please listen to it now. Listen to it again if you need to. Graph transformations of nonsensical or piecewise functions. For this particular part of this unit, we're not going to worry about graphing from an equation, meaning you don't need to know the x squared, the absolute value, all that kind of stuff. Simply put, a nonsensical function is a graph for which we won't worry about the exact equation. We're just going to call it f of x or g of x or h of x. Okay, and we're going to use similar notation. It's going to define the original, and then we're going to use that function notation and do stuff to it to tell you how to move it. It sounds kind of crazy, but here we go. Here's our first two examples. Example 1, f of x. It's this purple guy over here. This is our picture f of x. G of x is this pretty blue picture. That's it. That's all they are. Now, first we're going to look at reflections. Reflections are when there's a negative. Okay? If you see a negative, not subtracting, but a negative, basically multiplying by -1, then you know you have a reflection. The reflection will be either over the x-axis, meaning flipping upside down, or over the y-axis, flipping sideways. First, we're going to look at what happens when you flip upside down. You know that you're flipping upside down when the negative is on the outside. When we talk about outside, inside the parentheses or outside the parentheses. So on the outside always affects the vertical positioning of the graph. So a negative on the outside says I'm going to flip it over the x-axis. Now if you're on the x-axis, you're going to stay on the x-axis. But if you're not, here I'm 4 above, I'm going to go 4 below. I'm still on it. I'm 1 above, I'm 1 below. I'm 2 above, it goes 2 below. And then you do your best to mimic the curvature of the graph above. Some of you are going to be much better artists than others. This is the School for Performing Arts after all. Here I've taken f of x and reflected it over the x-axis, creating negative f of x. Now, if we want to reflect g of x over the x-axis to create negative g of x, I'm going to do the same thing. If I'm on the x-axis, I stay. But here I'm 3 below, so I go 3 above. I'm 2 below, it goes 2 above. 3 below, 3 above. Now notice if I'm on it, I stay on it. 1 above goes to 1 below and back on it. Then I'm going to connect the dots in a similar fashion to what they were before. And here, negative g of x is in red. It simply flipped over the x-axis. Next up is reflecting over the y-axis. This is on the inside. When we do something inside the parentheses, or inside the grouping symbols later, we're going to affect the horizontal positioning of the graph. So again, if you're on, now this time if you're on the y-axis, you stay on the y-axis. If you are on the left, you move to the right. If it's on the right, it moves to the left. Very, very simple. So 4 to the left moves 4 to the right. 2 to the left moves 2 to the right. We're on the y-axis, so we stay there. 1 to the left, 1 to the right. 4 to the right, 4 to the left. Notice I didn't change the y values, I just changed the x values. So going to graph, and there we go. Flipped over the y-axis, reflections. Now here, this one's kind of crazy because I'm going to take this guy right here, and I'm going to move him. Oops, if I can. Okay, we won't do it that way. It doesn't want to participate. So this is 4 to the left, 4 to the right. This is 1 to the left, so I go 1 to the right. This is on the y-axis. 1 to the right, 1 to the left. Notice that if it's symmetrical, you can't tell that particular part's been reflected. I can tell this part. Now this one is 3 to the right, so I'm going to go 3 to the left, 4 to the right, 4 to the left, and here is this graph. So you can tell that this has been reflected, but not because of this middle piece. It's because of the outside pieces. So again, a negative causes a reflection. Okay? Outside over X, inside over Y. Now, the next up is shifting or moving left, right, up, or down. First, let's look at shifting horizontally. So if I want to shift horizontally, remember that anything horizontal is inside. So I come down here, and there's a lot of words on this, and you can read it. Okay, if the original parent function y equals f of x, the translation, sliding of the function horizontally to the left or right, is given by f of x minus h. Here's the thing. We're looking at h. What is h? H is positive here, h is negative here. Notice that when h is negative, you get an x plus h on the inside. So, if we take a look over here, and we have f of x minus 4 is equal, we have h is 4, which means I'm going to shift this whole thing 4 to the right. So I take every point, and I shift it from where it is 4 places to the right. And then I redraw the graph. Here I've got f of x plus 3. H is negative 3 because remember, in order to make it into a subtraction problem, I have minus and negative. This tells me I'm going to move every point to the left 3. And 1, 2, 3. And then I can reconnect my points with nice straight / smooth curves. Okay, left and right. We'll do it again with this guy. Again, it's still the same thing, but just looking at different ones. G of x to g of x minus 4 means I'm going 4 to the right. H is 4. So I move everything 1, 2, 3, 4 to the right 4. And then I reconnect the points so that I've moved the picture to the right 4. Notice it hasn't changed size, and moving it to the left and right, it hasn't changed where it is vertically. The y values are all the same. It's just the x values of each point that have been altered. Moving to the left 3, same thing. X plus 3. This is the same thing as x minus negative 3. That's where I get that h is negative 3. And I'll show you a trick. Once I move this one to the right or to the left 3, I know I have this little semicircle, so I don't have to go back and count every one of those over again. I can just go from there. Then this is at 3. It's going to come back here, and I know this one is 1 down from it. So you don't always have to go from everything, go left and right. You can, once you have a point or two, you can sort of go from those points. Oops, it should be a straight line. Okay, there we go. Right 4, left 3. Now, in addition to moving left and right, you can move up and down. If you want to move diagonally, the way you move diagonally is to move left and up, left and down, right and up, right and down, something like that. So it's a combination of left or right and up and down to get diagonal movement. For vertical shifts, this is up and down. Vertical, remember anything vertical is outside. Horizontal is inside, vertical is outside. So I'm just going to add, okay? Movement is adding or subtracting. So if I add 4 on the outside, notice this is on the outside, not on the inside, it means I'm going to go up 4. So I take every single point and I move it up 4. Okay. Reconnecting those lines. Boom. I just took the whole picture and moved it up 4. Or f of x minus 3. K is negative 3. It went down 3. Again, you just take 1, 2, 3. You take each one of the points and move them down 3. And then reconnect the points. It's on the outside, so add outside is up, subtract outside is down. This is important even in drawing. If you're doing stuff with graphics in the computer works off of equations. Again, here's a vertical shift. We're simply using our other picture. If we want to go up 4, we add 4 on the outside. So we add 4 on the outside. We move this up 4, up 4. Boom, boom. Okay, and then down 3. We take each one of these points, 1, 2, 3, and we move it 1, 2, 3. We simply move it down 3 and reconnect. So much easier when it's not on a computer there. Okay? And let's see if I can, boom, boom. Okay. Now, in addition to reflecting and moving, we can also stretch or compress or deform a picture. Again, notice that if we stretch or compress horizontally, we are inside. Anytime you're inside, you're going from side to side. Okay, you're affecting it horizontally. Now, inside is always a little wacky. Remember we had x minus h? So when you were looking at the equation, it was kind of opposite what you might think right away. Same thing for stretching and compressing. And again, you can sit here and you can read, pause the video, and read the words. We're going to be looking at, however, the absolute value of A, not just A, I should say absolute value. When the absolute value of A is large, something compresses. When the absolute value of A is small, it stretches. Think about stuff on the inside like exercise. The more you exercise to lose weight and get skinny. So more exercise, you get skinnier. If you get lazy and sit around and don't do any exercise, you get wider. So, if we go f of x to f of 4x, this is 4 on the inside. That means we did, you want to think about it with exercise, 4 times the exercise, so 1/4 as wide. Okay? Which means that we have horizontally compressed by 1/4. When I ask you to describe it, that's where I'm going to be asking you to do. Horizontally compressed by 1/4. So if we take this, that means every one of these points will come in by 4. So instead of being out here at 4, it's going to be pressed in to -1. Instead of being at -2, it's going to be pressed into a half. Instead of at 1, at 1/4. Instead of at 4, it's going to come all the way back to 1. This one just stays here. So there we go. The other way to look at this is I can get 4 new graphs where I could get one of the original. 4 new graphs replace one of the original. Horizontal compression by 1/4. Now, if we look at the reverse of this and we go from f of x to f of 1/4 of x, that means we're stretching it. Got lazy. Instead of exercising 4 days a week, you only exercised 1 day. So you're going to get a little wider. And you're going to get wider by the reciprocal. The reciprocal of 1/4 is 4. So not enough exercise, got wider. We have a horizontal stretch by 4. That also means that I can fit 1/4 of this new thing where I fit one of the other. So with -4 stretches to -16. -2 stretches to -8. 0 times 4 is still 0. 1 times 4 is 4. And 4 times 4, stretch that out to 16. Now, I redraw the graph. And boom. The original is 1/4 the size of the new. The new is 4 times as wide. It's been stretched. All right? Let's try this with this shape. Try these two and then start the video again and check your answers. Sorry about that. I also had to get something for me to drink. It's just getting a little rusty. G of x to g of 4x did 4 times the exercise. You're going to get skinny by the reciprocal, 1/4. So we have our horizontal compression by 1/4. Anytime you move or stretch or compress, you have to tell me by how much and in which direction. So 1/4 of -4, remember it's -4 times 1/4. When you say of, it's multiplication, comes into -1. 1/4 of -1, right here at -1/4. The 0 stays at 0. Then we compress in from the right. We're getting this skinny little guy. Notice when we're doing this compression, he's not changing height, just changing width. 3 times 1/4 is 3/4. So he compresses into this guy. 4 compresses in to 1. And so we have, oops, this guy going on. So it's been pressed in from this side and this side towards the y-axis. Now what happens when instead of g of 4x, it's g of 1/4 of x? Oh, got lazy, so we're going to stretch it wide. -4 comes out to -16. That's -4 times 4. That's how I got the -16. -1 times 4 is -4. 0 times 4 is still 0. 4 times 1 is 4. 4 times 3 is 12. 4 times 4 is 16. Stretch it out. Stretch that way out. And here we go. Again, notice you stop exercising. You don't get taller. You don't get shorter. But boy, you get wider, right? So this guy got wider. Now, our last way of deforming or changing a picture is by vertically stretching or compressing. Again, this is vertical stretch or vertical compress. Now the nice thing with vertical, 1, you're on the outside. 2, it's exactly what it looks like. So If I tell you that I'm going to go from f of x to 3f of x, I'm multiplying on the outside, so I'm vertically stretching by 3. So this is going to multiply times the y value. Well, y value here is 0, so I stay at 0. Y value is 4 times 3 goes up to 12. Back down to 0. 3 times 1 is 3. 3 times 2 is 6. So here I am vertically stretching it. Did not change its width, just the height. Okay, just the height. I could stack 3 on top, 3 originals to get to this new one. If I compress it, that means everything's going to get pressed down towards the x-axis or up towards the x-axis. If it's on the x-axis, it stays. 1/4 of 4 is 1. 1/4 of 0 is 0. 1/4 of 1 is 1/4. 1/4 of 2. 1/4 of 2, sorry, is 1/4 of 2 is 1/2. And I'm putting that over there just because I know sometimes we have some trouble with fractions. Now, connect the lines. Oops, I don't know why that didn't. There we go. Connect the points with smooth curves. And again, you've now vertically compressed it. You've smashed it down. What about the other one? Can we do the same thing to it? Well, remember, it's not always by 4. You could do it by anything. Here, we're going to stretch it by 2. It's on the outside. 2. The absolute value of 2 is 2, so it's bigger than 1, so we're vertically stretching. Stays here. 2 times -3 is -6. 2 times -2 is -4. 2 times -3 is -6. 2 times 1 is 2. 2 times 0 is 0. I'm multiplying by the y value of each point. I reconnect. And there we go. Vertically stretch. We stretch above, we stretch below. We pull away from the x-axis when we're vertically stretching. When we're vertically compressing, we're going to press things closer to the x-axis. Down from above, up from below. If you're on the x-axis, you stay. 1/2. This is going to be half as tall. Half of -3 is -1.5. Half of -2 is -1. Half of -3 is -1.5. Half of 1 is 1/2. And then we're back here at 0. So we come down, over, up, and back down. And notice, any place where I'm on the x-axis, I stay on the x-axis. It was compressed from above and below. So vertical compression by 1/2. That's what the transformation is. Up here, this is a vertical stretch by 2. We use the word compress instead of shrink so that you can use an abbreviation VS or VC. All right? So, some practice with transformations. At this point, okay, just going to pull this down here and show you how you would do this. Okay? If you wanted to write an equation for the graph of g of x obtained by shifting the graph, f of x is equal to x squared. 3 units left, stretching the graph vertically by a factor of 2, reflecting that result of the x-axis and translating the graph up 4 units. One of the first things I want to show you is that this is f of x is equal to x squared. So remember, up, down, outside, left, right, inside. If we move down here, the transformations. This is taking that f of x, but now we're going to call it g of x because it's a new shape. And the first thing we want to do is move it 3 units left. So I have to affect the inside. 3 units left, that means h is -3. So minus a negative 3. That's where at the very end we're going to get plus 3. Vertically stretched by 2, that is going to affect this guy on the outside. So I've got my 2 here. Vertical equals outside parens. Reflect over the x-axis. The negative goes on the outside. 4 units up, I got to add 4 at the end. Down here I simply simplified the negative and negative. Right? We're going to do lots more of these. Here, if we go from f of x becomes g of x equals negative 5x plus 7, well, what have we done? First off, the negative in front says we reflected over the x-axis. The 5 tells us it's a vertical stretch of 5. And the plus 7 on the outside means it went up 7. Okay? If there are no parentheses, it's understood to be outside. These are linear transformations. And we're going to get into all these parent functions later, just giving you sort of a precursor, a taste of it, foreshadowing. G of x is equal to x plus 2. You now have parentheses. You're inside the parentheses, so that means you're doing something horizontally. Well, adding or subtracting means moving. So we are moving left 2. Why left and not right? Remember, it's x minus negative 2, so h is negative 2. Now, here are a bunch of graphs that you have on your paper there. Take a moment, decide what happens to each one of them, and try drawing it, and then come back and check your answers. Okay, hopefully you tried it. Let's go through all of these down below. First off, you have f of x plus 1 inside the parentheses, so it's left 1. Here's my little green graph that's left 1. Over here, f of x minus 2. K is negative 2. It's outside the parentheses, so it went down 2. Next, we have a negative inside the parentheses, so we're reflecting over the y-axis. By reflecting over the y-axis, we're changing the horizontal positioning of the graph. Inside, horizontal change. A negative on the outside indicates a vertical change, and in this case, it's a reflection over the x-axis. 2 times f of x. 2 is outside the parentheses, therefore I'm going to affect the up-down or the vertical. So this is a vertical stretch times 2. Notice every y value was multiplied by 2. Great job. Here's the summary. You have the summary at the bottom of your notes. Negatives are reflections. Okay? A negative is a reflection. Stretches and compresses, this is when we multiply. Okay? Inside, horizontal, outside, vertical. And then this is where we add or subtract. This is when we slide or move left, right, or up, down. So there's only 3 things: a negative, multiplication, adding or subtracting. Compounded by, is it inside or outside? Okay? That's transformations. This carries through the whole rest of the year.